All right, so just when you thought the C++ Renaissance was a marketing slogan, it's actually real. Here we are today. This is Going Native. It's a show on Channel 9 for native developers. My name's Charles.
I'm Diego Dagum.
Excellent. And what do you do, Diego?
I'm C++ community PM. I'm basically the link between you guys, the community, the C++ community, and the Visual C++ team.
Awesome. So we've done a lot of C++ content on Channel 9 recently. Not enough for many of you. That's going to change. We are bringing this show to you.
This is part of that.
Exactly. And let's talk about the Renaissance a little bit. I mean, when you think about what that means, what does it mean?
Yes, I mean, I was thinking about that for a while, honestly. I mean, because you can see that Renaissance is something that is subjective. You can say that maybe certain people who wasn't focusing on C++ is focusing on C++ today, while some other people was always focusing on C++. So we were checking certain stats on certain surveys we were doing, and we found that actually C++ has been being used extensively, you know, all this last decade, you know. So even in that period you were saying in Channel 9, for instance, we were not focusing much on C++. So we can say today C++ is, you know, an operating system we are all using, not necessarily Windows. It's in the web browsers we are all using to navigate the internet, not necessarily Internet Explorer, etc. C++ is everywhere, you know.
Absolutely.
You can find it also in any kind of form factors, etc. So it's really there. It's also, you know, there are certain myths that I'd like to talk about during this conversation, and we can try to demystify what happened with C++.
Well, hopefully over the whole course of the show, we're going to demystify some misperceptions. One of those misperceptions is that your classic or canonical C++ developer or native developer has gray hair and is sort of like a throwback to the 70s and 80s.
Absolutely.
What's going on here? What's the real in this?
It's good that you introduce the topic, because actually even when I talk with C++ developers, I mean, not maybe with people not having done C++ in the last 10 years, but even people in the C++ community, they consider that they are like some sort of the last crusaders, you know, using the language. And actually it's not like that, you know. So there are like a couple of myths regarding that the C++ community is shrinking. I mean, every day there are less and less C++ developers. Stats are not showing exactly that. And the other myth that the community is aging, you know. But you can check today in the curriculum in universities, C++ is being extensively used, you know, because it's actually one of the native languages more popular today. So the new generations of pro devs are coming out, you know, learning C++ today. That doesn't mean they are good C++ developers. At the minimum, they have breaking, you know, the barrier of, you know, the learning what C++ is about, what native developer is about, etc.
Well, that's one of the things, I mean, being this introduction, you know, this is our first show. One of the things we absolutely should talk about, because a lot of people watching this, a lot of people on Channel 9, for example, they're not native developers, right? They're going to be C# developers, for example.
Yes.
And there's nothing wrong with that. So I want to make it crystal clear that this isn't about change and you have to learn anything. It's about, if you want to learn about more native code, watch this. But if you're a skilled C++ developer, this show is for you as well.
Definitely.
Especially for you. So let's talk a little bit about, when do you go native?
Absolutely. Well, good question as well. For sure, it's like, as you were saying before, you know, this is nothing about, you know, moving people from one programming platform to another one. We still think, you know, there are some unique characteristics that C++ brings. For instance, C++, as any other native language, gives you access to any feature that the underlying operating system is offering for you, you know. This is not necessarily the case in managed languages like Java or C#. It's like you have a framework that is very powerful. You can do everything that the framework is allowing to you, but if by chance you want to do something that is not allowed for the framework, well, native development is, again, you know, an attractive option. So we are talking today about a new generation of applications that are coming, you know, with natural user interfaces, for instance, augmented reality, etc., and, you know, applications that are really pushing the envelope. When you think on coding your applications yourself, native development and C++ in particular is a good option.
Absolutely.
Another case you may consider is also performance, for sure, because you don't have, like how can I say, like a virtual environment, like the Java virtual machine or the common language runtime, that is managing the application you are running on top of that. You are just, running your application on the metal. For sure, it's expected that it's going to be faster, and benchmarks are showing so.
Absolutely, absolutely. Well, in the case of the CLR and the JVM, the metal is the JVR, is the JVM and the CLR.
Absolutely.
It's a proxy to the real metal. With native code, you get right to the metal, brothers and sisters, and that's the point, right? Now, of course, the great thing about the language is that it's very abstract.
Sure.
And in some of the demos that we're going to see today, you're not going to see the little strange kind of syntax you might have thought it would be in the C++ of our fathers, and certainly the case with C. But it looks very clean and fresh and nice.
Absolutely.
And very highly abstracted, yet is very powerful and gets right down to the machine in very efficient ways. So that's the power performance you were mentioning.
Yes, absolutely. When I talk with the community, and particularly people who knew C++, but they stopped using maybe in the late 90s, in the early 2000s. It's like they have that image of C++ being some sort of spaghetti code and a bit scary code, because it's like everything was mixed all together, and you have to take, into account what you were doing with the memory you were using directly, etc. C++ for sure has been evolved, I mean, of course those were problems in the past, but it's like the industry and particularly the standard committees were focusing on those problems. And if you take a look to the modern C++ today, I dare to say that it looks like, the kind of style you can find in C# or Java or any other modern language today, without resigning anything about the power and performance.
Excellent, which is very impressive, about levels of abstraction without compromising performance.
Absolutely.
That's one of the guarantees the language provides. Now, one of the things we're not going to do on this show is talk a lot. So I'd like, if you don't mind, one of these abstractions that's very interesting, you mentioned the memory word.
Sure.
Shared pointer.
All right, so what we have here, we have this, this example function, example usage. And what we can see here is that we are allocating memory for a myClass instance that is being given to ptr0 pointer. And then we are assigning also, we are creating more pointers to that, and we are assigning the same object that was allocated. But we can see that when we leave this function, we are not releasing the memory. So this method is explicitly leaking memory. We can confirm that because here we have the class. So when the class is destroyed, it should print out, this message that the class is being destroyed. And if we run this demo, that is pretty simple, it's pretty simple. We can see that the main method just called this function. We should see that the structure of the class will be never called. So I put the breakpoint, after we left example usage, where all the three variables were gone. And we can see, that the class was created. Some usage we did with the class is printing out certain messages out there, but nothing else. I mean, the structure was never called. So in this case, we are explicitly leaking memory. This is the traditional way of dealing with pointers. Okay, so let's finish this. And what I'm going to do now is I will comment this line. I don't want to lose them, but I won't use it for the rest of this demo. I'm using now share pointer. This is the structure we have talked before. So with share pointer, we can see, the syntax is, different. However, you can see that it's actually the same kind of thing. So I'm going to run this again. Something I want you to notice is that I only change the declaration of these pointers, but not the way I'm using these pointers. I use those the same way I typically have used any pointer. When we check what the application did, after we left the function, what it happens is that these variables, these pointer variables lose visibility, and the last one, it destroys the class. So it's like the memory is recovered.
Right on, man. Very cool. Very simple.
Absolutely. You can learn more, I mean, Stefan has made, a complete lecture about shared pointers, Shared pointer is just one of the examples of smart pointers that are a new generation of pointers that came, for C++ development. They are part of the standard, so you may consider that as, today, part of the language, if you like. Yes.
Things in C++11 that people really love, like things that really help C++ amp out, for example, are lambdas.
Absolutely. Well, in this case, we are going to see an example of a lambda function. So I'm not going to come into the details of how a lambda function should be defined, but C++ developers may be familiar with the for each algorithm that is part of the standard template library. You define, like a position, an initial position, a final position, and what this algorithm does is applies certain function to all the elements in that collection. So what we are doing in this method, for instance, is we are creating a vector and we are filling this vector with the numbers from 0 to 9. And then what we are trying to determine is whether each element is even or odd. So in this case, before lambdas, we should have to define like a separated functor or function object. And you can see here that it's actually not much complicated, it's just one line of code, So in this case, I mean, in my particular example, it was well justified. I don't need to create really a separated class. I can just put all the syntax together, and that makes everything a bit more productive. So let's see it in practice. All right, I put a breakpoint at the end, and we can see here, the expected result. So as I told before, I'm not coming to the internals of how a lambda should be defined, the different possibilities, etc. But there is an interesting lecture you can see, and you can learn all those details on your own.
All right, so that was really simple. Lambdas are super powerful. I also noticed that you use an auto in there, so that's type inference.
Yes, I can explain very briefly. It's like autos try to solve the problem of having to remember, complex class names, or types, when you are doing something. For instance, that the vector class, you can call the method begin, and the method will return an iterator. But you don't remember exactly, the class type. I mean, the
variable
type name.
Yeah.
Absolutely. So it's like you just put auto as declarator. You get that, and in compile time, it's like everything is inferred and the type is inferred. It's pretty similar if you are C# developers. It's pretty similar to the bar.
Yeah, exactly.
Modifier,
It's exactly the same. Very cool. And that, I mean, I wanted to quickly just say something, about this, and that is, this isn't an introduction to C++ course, but what Diego has shown and you've seen in the demos is useful for you if you're a C# developer. It does look pretty familiar, doesn't it? It doesn't look this out of the world, this weird. Modern C++ is a very fresh and beautiful syntax, so it's very important for people to, I just want to throw it out there. So now let's move on.
Absolutely.
Right? Because we have to be performant. The next thing we should discuss is, the audience, right? This is the most important thing. I mean, we've been talking about it a little bit on the internet recently about you're going to help us drive this show.
Absolutely.
What do you want to see? Who do you want to meet? How do you want us to organize this show? We're doing it on the fly in Channel 9 style today, but we want to know.
Yes, I have something else to tell. This is all about, this is not necessarily, like a full-length lecture, This is more about community facts about C++,
Yeah.
So I want to take the opportunity to invite you guys, if you want to participate of this program, I mean, by sending us your blog post, by sending us even your videos or whatever you want to publish, your projects, I mean, open source project you are doing, etc., as part of a community effort in order to make the C++ community, better connected, and more consistent, more powerful, etc. Please, this is your opportunity.
Absolutely, and as we've said earlier, C++ is a portable language, and by that, we're not just going to focus on Microsoft. So, really importantly, send us your mails to C9GoingNative, one word, at hotmail.com, and follow at C9GoingNative, so you can take advantage of the tweetosphere and all that kind of weird stuff. So we have a little bit of a social fabric presence. Excellent. So one of the things that we are doing on this show is we're not going to spend the whole time in the studio, man, because we want to get out into the real world and meet some real devs who are writing code. And who are we going to talk to today?
I think we are interviewing Ale Contenti.
Yes.
You know? Ale is an engineer in the Visual C++ team, so he's manager of engineers today, and he's willing to receive us this afternoon.
Absolutely. So, well, let's go ahead and talk to Ale. All right, we're with Ale Contenti.
Hello.
Nice to see you again.
Yeah, of course.
You've been on Channel 9 for many years.
Yeah.
So this is part of Going Native. We're going around,
Okay.
and we're going to talk to native developers and people who've been in this space for a long time.
Right.
So tell us what you do.
My name is Ale Contenti. I'm the development manager for the C++ experience, we call it, because under me I have a team that works on the libraries, a team that works on the front-end compiler, and a team that works on the IDE, so project system and IDE, the IntelliSense and so on.
Excellent.
So technically we have two compilers, one to compile the code and emit the exe, and one to compile and actually emit all the information we keep in the IntelliSense.
Nice.
And all the libraries like your favorite STL and so on. So I like the going native things because this is kind of going native twice, right? So we write almost basically everything in C++ to enable C++, to enable native. That's pretty cool.
Excellent. And let's talk a little about why you do that, because you talk about it as a language of performance.
Yes.
And power.
And power and performance.
Yeah.
I mean, in a certain sense, you can control very, very well, you know, the amount of memory you have. And the problems we have, you know, with IntelliSense, a large amount of data and, you know, or compilation throughput faster and so on. So, you know, PCH. For example, the trick we do when you include Windows.h, it's a lot of symbol, right? A huge amount of stuff, right? So we parse all that, and usually what we tell people, put that in a PCH. That is basically just a blob of memory that you put on disk, then you load it up. And you load it up as it is, right? So that's some of the things that it's really easy to do in Windows, using Windows with the, you know, with the virtual unlock and so on. And you basically memory map the file, and you have it already there. You don't have to reparse everything. So that's just a quick example. I just thought about it.
Excellent.
But you know, those things are very natural in native because you have a pointer to memory all the time, and not so natural in other type of languages, right?
Sure.
So when you need it, it's useful.
Excellent. So now, when did you
sometimes.
first become a C++ developer or a native dev? When did you get into this?
Yeah, I was thinking about that a little bit. You know, I started actually. You know, I started a long time ago when I was a kid with my dad, and he bought an old Commodore VIC-20. So I started with BASIC, and then you know, BASIC was super slow because it was interpreted. So we went into assembler very quick, right? The 6502 assembler, you know, it's under a RISC. And then I improved, and I did Pascal, then Turbo Pascal. And Turbo Pascal came out with the objected version. So I remember I learned object-oriented with Turbo Pascal, right? And then at that moment I did the switch to Borland C++. And I remember still those large books where I learned the examples of, you know, the point and the inheritance, you know, to make a shape, a rectangle with 2 points, a triangle, and you have a general thing. So that's more or less. Basically, I learned by myself, then I studied a bit in school, and then I started writing more and more programs, right? And then I joined Microsoft in 2000, and I've been writing C++ since then, I guess.
Nice.
I think for a year I wrote a little bit more C#.
Sure.
Because I was in the web designer. It was pretty cool too.
Really?
Yeah.
Nice.
Then I came back to the libraries team. I started writing a lot of libraries in, you know, STL. I learned very well STL. I learned all the tricks about template metaprogramming. That was fun.
Yes.
And you know, I actually used them recently. Maybe last year, I wrote a nice prototype that used a bunch of stuff around, you know, template metaprogramming and so on.
Yeah.
Looking at some ATL patterns, and it was pretty cool. It's always fun.
Yeah.
When you look at the code though, after 2 months, you say, "Oh, Jesus, what did I write here?" But you know what? Then you say, "Oh yeah." So yeah, but you know, because then I gave the prototype to someone else to actually refine it and make it a nice library. So, but that was fun. Yeah, it's always fun.
Absolutely. Now, you bring up an interesting point because you know C++ is a very big language, right?
Yeah.
And definitely complicated. You have several different ways to play with strings. The amount of types are ridiculous. Everything. Talk to me a little bit about some of your favorite and least favorite things of the language.
Yeah. So let's say one of the favorite things I grew up in the library space, so I really like that part. I really like the power of the language that the language gives you to actually make the language bigger with libraries in a very elegant way, right? If you think about share pointer or things like that, those are extremely powerful tools that are written in the libraries with a very little help, very general help from the compiler itself. So the compiler is making some key changes, giving you, R value references. And then you leverage them like crazy in the libraries, right? When you have a very large vector, you can flip it around with an R value, with a move constructor. To get all the details, just go and look the STL section that you're gonna put down in the notes for sure. But the symbiosis is great. The front end changes, the syntax changes, and then the library changes. They leverage that. So that's what I like a lot. It's a very well designed language, very powerful. So what the other flip of the coin is that it's a language that has been around also very, very many years. So it came from C and so on. So there is a lot of ways to do the same thing, in 5, 6, 7, 8 times. Plus we have Windows underneath. There is Windows 32. Thinking about strings or copying a string or concatenating strings, there are so many ways, so many libraries and way to do it in the language. And that thing I don't like. That thing I don't like, and I think I blame a little bit us because in a certain sense we didn't step up and say, okay, let's do it this way. Just do it this way. Shut up. This is the way to do it, and I think I want to do that a little bit more. I want to be a little bit more prescriptive. I was just remembering talking with a friend before. I say, well, one of the classical things that Strauss-Trup says, you always think about a string class. You always write your own string class. You write it up because you want to understand how it works. Then you look at it, you take it away, you throw it away, and you use standard W string, right? And that's what we want to tell other people, right? So there is maybe we pushed out libraries all the time that do a string a little faster, a little bit different, or many different things like calculation and so on. So I want to be a little bit more prescriptive about that.
Absolutely.
So that's the thing I envy sometimes in other languages, right?
Sure.
Yeah, so that's cool though.
Yeah, absolutely. Now, one of the things that you've done, and we've actually talked to you on Channel 9 about this, I think about 4 years ago, is this sort of the secure coding.
Oh, yeah.
C++ is one of those languages where you can blow your feet off.
Yep.
And things aren't done to help you not blow your feet off in terms of like what we get when we have verifiably type safe code.
Exactly.
You guys are type safe, but you can cast. You have C casts.
Yeah.
That's one example.
Yeah.
Can you talk a little bit about how that's changing?
And that's again another example of how you power both the syntax changes in the front end compiler or in the back end compiler, and in the libraries, right? So other things, for example, so you can approach the problem in different parts. For example, you can write. For example, we wrote the CRT, the secure CRT library, right? The underscore S function, and then went back into the C standard, right? To actually deprecate, in a certain sense, the old functions that are not safe. But we add a lot of things, some things in the compiler, like all the analyze things like lint or our /analyze, the static analysis that actually just look at your code and tell you, well, don't do this because you are doing a buffer overrun right there. I can see it, right? And or other things that we can do in the libraries. The libraries sometimes are powerful enough that they can pick up the size of the buffer for you through some template magic. Then you don't even have to change the code, right? Or then again, if you go down to the backend compiler, let's say you are building like 100 files, 100 CPP files, 100 OBJs. When you link them together, we link them with what we call link time code generation, LTCG. They look at the entire 100 OBJs, and smoosh all the code together. So at that moment, the backend compiler has the entire tree of what you're trying to do. They understand basically everything, and they can see things you're doing wrong. For example, sometimes we are one of the bad things you can do in C, because it was C, because this loosely coupled, linking generation and so on, the code generation and linking is what we call the ODR, one definition rule violation, right? So you define something in this CPP file, and you define it here, usually because you do a pound define macro different.
Okay.
And now these things are actually different, but the compiler is compiling this one, then it's compiling this one, it doesn't know. It's just compiling stuff. But the linker, when the backend compiler, when it's actually putting the exe together, can see these two structs, these two classes. They have different layouts, and it's going to tell you, wait, watch out, what you're doing, right? So that's another tool that make your program more secure. That kind of removes these kind of blocks these bad things you can do, in different parts of the toolset, right? So.
Excellent.
Yeah, there's always a little bit more we can do, and we are always pushing it to be more, canary checks, like the GS switch and stuff like that. So we always work with very cool people. Actually, they are not even here. They come every month from England. Our security researcher there.
Nice.
And, they check in our code all the time. It's very cool. Yeah.
Good.
Yeah, there's nice stuff going on. Yeah.
Excellent. Well, hey, it's great to come and talk to you again.
Absolutely, yeah.
And it's nice to learn about your history and ideas and
Yeah.
thoughts about this. So thanks for coming on Going Native.
Absolutely, yes.
And hopefully we'll come and see you again.
Going native, yeah. I'm gonna see you soon. Bye,
Right on.
guys.
Ciao.
Ciao.
All right, that was great, right? I mean, we always love getting a chance to talk to Ale.
He's a nice guy.
He is a nice guy. He's also, everyone knows Stefan T. Lavaway, STL we call him. I mean, that is his how did he get that alias? It's killer, man, STL.
Yeah, no.
He's actually, Ale is STL's grand boss, right? And so he's also, basically, so he owns our implementation of the STL and a bunch of other libraries. I mean, basically, he owns all the libraries and stuff.
Sure.
One of the things, people have watched this interview back in the past, and we talked to Ali about it already, was the notion of writing more secure libraries, helping developers not write insecure code. Now, one of the things C++ has been, arguably and deservedly so, criticized about is the ability to write code that blows your feet off.
Yes.
So let's talk about that.
Well, of course, it's in certain way part of the trade-off. When you have something that is powerful, it will depend on the way you use it. If you don't use it consciously, it could be actually harmful. And for sure, I mean, for instance, a typical case is buffer overrun. You provide a pointer to something, and somebody gets access to that pointer and can, just try to step into the memory and change everything, even beyond the boundaries of the original element you were pointing to, So there are ways to mitigate that. For sure, there are certain best practices like threat modeling, etc., and a lot of things, a lot of, in certain way, measures or countermeasures you can take. But it's something, that any developer must be conscious about. This is powerful. At the same time, it will depend on the way you use it.
It's true, and I mean, I sort of had an argument, an interesting thread on Lambda the Ultimate, which is a great programming languages sort of community, which of course isn't going to be very big.
Yes.
These are the people that design languages and whatever, throw languages away, build new ones.
Sure.
C++ is not their favorite language. And part of the problem is, I would imagine, is it's too big in their minds, too complicated, and dangerous. But what I was trying to argue in that case, certainly out of my league on that thread, but nevertheless, was that is just exactly what you said, right?
Yes.
If I provide you with a weapon,
Sure.
How you use it is up to you.
Totally, and actually, this is nothing that you say is exclusive to C++. I mean, for sure, I haven't been coding C++ my whole life. I have been trying other programming languages, and we also have to take, security measurement. I mean, for instance, SQL injection or that kind of, of attacks may happen on other languages as well. So it's nothing that is exclusive. I can take, for instance, I want to tell an anecdote. Regarding this. Maybe not much about security, but about scalability of applications. I remember a project on a managed language I used to work in the past. I remember that unbelievably was leaking memory. It has, the garbage collector but the garbage collector was not collecting that memory, never, Was a bug in the garbage collector? No, was a bug in the application. Actually, in Java and C# or .NET in general, it's like, variables or the memory occupied by the objects in memory are being collected as long as they are not being referenced by any variable in the rest of the application. And what it happens is that we have like a sort of overall status complex data structure, and accidentally somebody was pushing in a certain way a pointer, actually a reference to an object that we were expected was a big object, and we were expected that the object should have been garbage collected. But because it was being pointed, the object was always there, So this is one case that I can say even in managed languages, you don't have, the problem totally solved. About security in, in native or managed languages, you have maybe certain memory areas that you can inspect, with a debugger or something, So you must protect, let's say, a password or a credit card, and you have no warranties, not in C++, but in any language. You have no warranties if you don't take countermeasures that actually, you can inspect certain areas of memory and later, print that out in any other place, So
sure.
It's something that security...
You can write bad code in any language.
Sure.
Right?
Absolutely. I mean, in order to deal with security, I don't believe that the way to deal with that is just change the programming language. It has to do with the practices when you write code, So
absolutely. Well,
it may be arguable, but
productivity is important as well. And certainly, as the language has evolved, you can become more productive in it.
Sure.
Certainly more productive than you are in C. I mean, that's arguable for our C friends out there. No offense, but I think the higher level abstraction without losing performance, that's rock and roll. So let's destruct C9 going native. Just so people know, in our own little show notes, we have a constructor and a destructor.
If we are members of C99 going native,
we
are going to be distracted as well.
But that's okay, man, because we can come back. We have a special kind of destruction.
Okay.
Right? Because we can be resurrected. And we'll be resurrected once a month, by the way. This is going to be a monthly show.
Sure.
So conclusion for today is, hey, the C++ Renaissance at Microsoft is real. We're going to spend a lot of time and effort building really good episodes of this show with good guests and great demos and tips and tricks and bring the community in and really kind of go native.
Absolutely. There are more things to happen. We are not telling, and we are conscious that we are not answering all the questions you guys are asking us in the blog, in Twitter, etc. However, it's like there are more things coming, so.
Sure. So, and just for fun, I mean, here's what's going to happen. The first question is going to be, we need native on WP7. Great. The second question will be what?
Well, there is a question that it's coming, over and over. That is, that you guys tell us that you need a abstraction framework, maybe superseding MFC or something different than what we are offering today. I'm just saying by this time, we have ears, we are hearing, we are working. You are going to know.
Exactly. Perfect. So just keep talking, and we're not always going to get a specific answer, but people are listening. I mean, all the way up the chain. So talk to us at C9 Native on Twitter. You can tweet us questions. You can tweet us whatever you want. Tell us what you want to know. Who do you want to see next? And again, finally, it's not just about C++. I want to get Walter Bright on here. I want to geek out on D. D's really interesting. So maybe we could get Rob Pike.
Absolutely.
And geek out on Go. So rock and roll, man.
Okay.
It's great to have you along.
It was a pleasure for me.
It's nice to get people to meet Diego. I mean, you're the guy behind the VC blog. No one really knows you. Your picture's on there, though.
Yeah, I think so.
Right on, man. So we're really lucky to have a practitioner as our host. So rock and roll.
Okay.
Go native.
See you.